Good, good evening, sir.
Good evening, sir.
Good evening. Am I audible?
Yes, sir. শুনতে পাচ্ছি।
আচ্ছা, একটু কি হেল্প করবি যে লাস্ট টপিক we have completed in acid base salt?
আমরা অ্যাসিড বেস সল্টে মানে লেকচার 2 কমপ্লিট করেছিলাম।
Lecture 2.
2, হ্যাঁ।
Just see this. This one is lecture 2 where we discuss about the Arrhenius theory.
হ্যাঁ, আরএনএস থিওরি লাস্ট হয়েছিল। মানে লাস্ট ক্লাস হয়েছে।
Bronsted-Lowry, is it completed?
হ্যাঁ।
Bronsted-Lowry, Arrhenius concept. This one, hydronium ion formation or formation of ammonium hydroxide, lone pair, etc.
হ্যাঁ,
এগুলো কমপ্লিট করেছি, তাই তো? প্রিপারেশন অফ অ্যাসিড,
স্যার প্রিপারেশন অফ অ্যাসিডের মানে একটুখানি এগিয়েছিল, মানে প্রিপারেশন অফ অ্যাসিডটাও হয়েছিল।
প্রিপারেশন অফ অ্যাসিড হয়েছে।
হ্যাঁ, এগুলো হয়েছিল। হ্যাঁ, এইগুলো হয়নি, ওই আগের গুলো হয়নি, এইগুলো হয়নি।
ডিসপ্লেসমেন্ট রিঅ্যাকশন হয়নি?
না, অক্সিডেশনও হয়নি, ডিসপ্লেসমেন্ট হয়নি। হ্যাঁ, এইখান থেকে হবে।
চলো, ওকে। Here we see some other students. Sonal,
Yes, sir.
can you hear me?
Yes, sir, I can hear you.
Okay, your friend
Avika.
Ovika, can you hear me?
Yes, sir.
Okay. Do you start this particular chapter? That is acid-base salt. Sonal,
Yes, sir.
do we start this chapter, acid-base salt? Have you any conception about the definition of acids and bases and salts?
We actually started a bit in school, only some part.
Already we have completed 2 lectures of this particular chapter. Today is the 3rd day of this chapter, so I think if you should face some problem understanding the concepts of acids and bases, then just hand rise, and I should discuss it again and again. So because of the fact that this is our third class in this particular chapter, so may so happen that you should not get a correct conception about this chapter. So I can tell you that if you face any problem, then you should communicate. Okay.
Okay, sir.
Okay.
Okay, sir.
So today we want to continue this particular chapter, that is acids, bases and salt. This is our third lecture. First, we want to prepare acids by the oxidation of non-metals. Now, non-metals are those are present in the period table, like nitrogen, like phosphorus, like sulfur. These are the non-metals. Okay. By the oxidation of non-metals. Now see, a non-metal like sulfur or phosphorus. Sulfur is a non-metal and phosphorus is also non-metal. They oxidized by concentrated nitric acid. So concentrated nitric acid is a very, very strong oxidizing agent. Okay, this is very strong oxidizing agent. Why nitric acid is very strong oxidizing agent? Because nitric acid itself, it dissociates with the formation of nitrogen dioxide, water, and nascent oxygen. This is nascent oxygen. Nascent oxygen means atomic oxygen. This is responsible for oxidation. This is responsible for oxidation. So when nitric acid reacts with sulfur, nitric acid oxidizes sulfur. Nitric acid oxidizes sulfur with the formation of sulfuric acid, and itself reduced. When a particular oxidizing agent oxidizes other, then itself get reduced. So nitric acid oxidizes sulfur. Nitric acid oxidizes sulfur to convert it sulfuric acid, and nitric acid itself get reduced with the formation of nitrogen dioxide. This is a general rule that when an oxidizing agent oxidizes others, then itself get reduced. Is it clear? Is it clear to you? Patikrit, Boidurjo?
Yes, sir.
If an oxidizing agent oxidizes other, then itself get reduced with the formation of nitric acid, itself get reduced with the formation of nitrogen dioxide. So by this method, you can convert sulfur into sulfuric acid. Now, this type of question may be asked in the question paper in the exam. That is, how will you convert sulfur into sulfuric acid? Elemental sulfur into sulfuric acid. Then you should say that if elemental sulfur reacts with concentrated nitric acid, then sulfur oxidized to sulfuric acid and nitric acid itself reduced to nitrogen dioxide. The similar is the case when phosphorus reacts with nitric acid, like nitric acid, HNO3, it reacts with phosphorus. Then it is phosphorus converted into phosphoric acid. What is the formula of phosphoric acid? This is H3PO4, and as usual, water with nitrogen dioxide. So sulfur and phosphorus may be converted into corresponding sulfuric acid and phosphoric acid on reaction with nitric acid. So carefully follow the reactions, which one is oxidizing agent, which one is reducing agent, because next week we should take some MCQ test From this part today, that this particular part, which part we discussed, that particular part, we take some test, MCQ test. Then, then these are the important part of this particular chapter. So this is the method of preparation or method of conversion of non-metals into corresponding acids. So oxidation of non-metal, where sulfur and phosphorus oxidized to form sulfuric acid and phosphoric acid. Now another important method where displacement reaction. What is displacement reaction? Displacement reaction, previously we have discussed about the displacement reaction. In displacement reaction, now one metal may be displaced by the other, like these are one type of displacement reaction, like when copper sulfate reacts with okay, Sonal.
Sir, could you repeat why concentrated nitric acid is a very strong oxidizing agent?
Why nitric acid is very strong oxidizing agent?
Yes.
Okay, nitric acid is very strong oxidizing agent because nitric acid itself get dissociated with the formation of nitrogen dioxide, water, and this is nascent oxygen. This is known as nascent, NaCNT, nascent oxygen. Okay, now nascent oxygen means it is a very highly reactive oxygen, that is atomic oxygen. As we all know that what is oxidation? Oxidation means addition of oxygen. Now because of the fact that nitric acid dissociates to form this atomic oxygen, so this atomic oxygen get attached to other element like sulfur and convert it into sulfur dioxide, which again converted into sulfuric acid. So that's why nitric acid is considered as very strong oxidizing agent. Is it clear to you?
Yes, sir. Thank you.
So here, what is displacement reaction? Displacement reaction means where any metal, any reactive metal, in some of the reactions where you see that when copper sulfate reacts with iron, copper sulfate reacts with iron. Now because of the fact that copper is less reactive than that of iron, this is reactivity order. So iron is much more reactive with copper, and so iron displaces copper from copper sulfate with the formation of ferrous sulfate and copper. This type of reaction is known as displacement reaction. Okay. Now, in this case, where some more volatile acids, here we see that more volatile acid. Now, volatile acid means the acids having low boiling point. Volatile acid means acids having low boiling point. Okay, like hydrochloric acid, like nitric acid. These acids having very low boiling point, those acids are known as volatile acids, are displaced by less or non-volatile acids. Non-volatile acid means acids having high boiling point, like sulfuric acid. So sulfuric acid can be used to prepare a more volatile acid like hydrochloric acid or nitric acid. So here we can write that a less volatile acid can be used to prepare a more volatile acid. So sulfuric acid can be used to prepare more volatile acids like hydrochloric acid or nitric acid. How is that possible? Just see here we give some diagrammatic representation where we take some sodium nitrate in this round bottom flask, sodium nitrate, and add some sulfuric acid. Here you see that we take some sodium nitrate, NaNO3, and add, here it is sodium nitrate and sulfuric acid. Okay, so sodium nitrate and sulfuric acid, NaNO3, by the addition of concentrated sulfuric acid, they react with each other with the formation of NaHSO4 and nitric acid vapor. This is nitric acid vapor. Here sodium nitrate and sulfuric acid react with each other here, and the formation of nitric acid vapor, HNO3 vapor. Now this vapor should be condensed by the spray of cold water. Here you see that spray of cold water occurs and we get some concentrated nitric acid as a liquid in this container. So this is the process. This is the process of formation of the preparation of nitric acid starting from sodium nitrate. Just see, potassium nitrate, you can also use potassium nitrate in place of sodium nitrate. So sodium nitrate and sulfuric acid, they react with each other with the formation of potassium bisulfate and nitric acid. The temperature generally used in this reaction is around 200 degrees Celsius or less than 200 degrees Celsius. If the temperature maintained above 200 degrees Celsius, if you maintain this temperature above 200 degrees Celsius, then what happened? What's the problem? The problem is that above 200 degrees Celsius, KNO3 reacts with H2SO4 with the formation of K2SO4 and HNO3. Now above 200 degrees Celsius or below 200 degrees Celsius, in both the cases nitric acid is formed as usual. But in case of this reaction where the temperature kept below 200 degrees Celsius, we get potassium bisulfate. But if you maintain a temperature above 200 degrees Celsius, then you should get potassium sulfate. Now, what is the problem of formation of potassium sulfate? Now, potassium sulfate is a very sticky substance. Sticky substance means it is get attached with glass container and very difficult to remove that sticky substance from the glass container. Okay, so the temperature generally maintained below that of 200 degrees Celsius. Otherwise, potassium sulfate or sodium sulfate will be formed, and sodium sulfate and potassium sulfate, they are highly sticky substance. They get stuck with the glass container and it is quite difficult to remove them or to wash the glass containers, and these are the major problem. And if you maintain a temperature above 200 degrees Celsius, then there is also possibility of the crack of glass vessels. These are general problems. So if anyone asks this type of questions like, in this reaction or in the preparation of nitric acid or hydrochloric acid, why we should maintain a temperature below that of 200 degrees Celsius, the answer will be like this, that if we maintain a temperature above 200 degrees Celsius, then we should get potassium or sodium sulfate salt, and generally those sulfate salts are highly sticky one, and due to this particular nature, those substances uh, uh, are attached with the glass container, and the washing of glass container or the removal of this sticky substance from the glass container is quite difficult. That's why we should maintain a temperature below that of 200 degrees Celsius. Is it clear to you, all of you?
Yes.
Just then. Okay. এক মিনিট কি আবার হ্যালো হ্যাঁ হ্যাঁ বলুন আচ্ছা ঠিক আছে দেখে নাও কোনো প্রবলেম নেই ঠিক আছে হুম So this is a displacement reaction. In this displacement reaction, you see that sulfuric acid can be used to prepare nitric acid or hydrochloric acid, because sulfuric acid is less volatile. So the less volatile acid can be used to prepare a more volatile acid like nitric acid or hydrochloric acid. Those acids are more volatile. That's why the less volatile acid can displace. This is a displacement reaction where the more volatile acid can displace a less volatile acid can displace a more volatile acid like nitric acid or hydrochloric acid. Now next, now we should discuss about the preparation of bases. Now, can you define the Pothikrit? Can you define what do you mean by base?
So base is a substance which on its complete dissociation only gives hydroxyl ion as the only negative ion.
Exactly. Okay, thank you. Bases are such a substance. Bases are such a substance. Those substances are generally metallic oxides or hydroxides. Bases are such a substance. Those are metallic oxides or hydroxide, like sodium oxide. This is base, or you can say sodium hydroxide. This is also base, because they, when added into water, they produce hydroxyl ion as the only negative ion. So those substances should be termed as base, which in solution, in aqueous solution, produces hydroxyl ion or OH minus ion as the only negative ion. Like if you consider the sodium hydroxide, then sodium hydroxide in aqueous solution, it dissociates the formation of Na plus and OH minus. This is the only negative ion that is produced by sodium hydroxide. That's why sodium hydroxide can be termed as a base. Or even sodium oxide, when dissolved in water, it produces sodium hydroxide, and this sodium hydroxide again dissociates with the formation of Na plus and OH minus. That's why sodium oxide or sodium hydroxide, whatever might be, they should be termed as base. Now we should discuss about the preparation of the bases. Now this is the reactivity series or the metal activity series. In the metal activity series, we arrange the metals in such a way that the upper part or uppermost part, it contains those metals which are highly reactive. like starting from sodium, lithium, calcium, magnesium, aluminium, and then zinc, iron, etc. So the elements present in the top of the metal activity series, that is sodium or lithium or calcium or even magnesium, those are highly reactive. So when these metals react with oxygen, this is the direct combination between highly reactive metal with oxygen. So sodium is highly reactive. Sodium is highly reactive. Potassium is also highly reactive. Do you know why sodium is highly reactive? Why sodium is highly reactive, or even potassium? Sodium or potassium is highly reactive. Can anyone answer me?
স্যার সোডিয়াম আর পটাশিয়ামের ইলেকট্রনিক কনফিগারেশনটা কি আনস্টেবল?
Why it is unstable?
স্যার কারণ কি ওদের একটা একটা ইলেকট্রন আছে আউটার মোস্ট শেলে।
Exactly, very good. So if you consider the electronic configuration of sodium, like sodium, it contains 11 electrons, or even potassium, it contains 19 electrons. So its electronic configuration is something like this: 2, 8, 1. And because of the fact that sodium contains only one electron, or in case of potassium it is 2, 8, 8, 1, it also contains only one electron. So if any element, they having 1 or 2 electrons in the outermost shell, they easily lose that electron to get the nearest inert gas configuration, and that's why these elements are highly reactive. Sodium or potassium is highly reactive only because of the fact that they contains only one electron in their outermost shell, and after the removal of those electrons, those single electron in the outermost shell, the electronic configuration of sodium or potassium is converted into nearest inert gas configuration, which is highly stable. If the outermost shell contains 8 electrons, then that particular element will be highly stable. So here you see that sodium, after the removal of one electron, sodium is converted into sodium plus, and its electronic configuration will be 2,8, which is the electronic configuration of neon. So that's why sodium easily removes one electron, and that's why sodium is highly reactive. And sodium at normal temperature, it reacts with oxygen present in the air. That's why sodium is kept under kerosene. Sodium is kept under kerosene only because sodium or potassium or lithium, these elements are kept under kerosene because sodium or potassium, they react with oxygen present in air quickly to form sodium oxide, or even potassium reacts with oxygen with the formation of potassium oxide. In order to cut off the reaction between oxygen and sodium, those metals are kept under kerosene. Otherwise, when those metals comes in contact with air, the oxygen present in air, they violently react with those metals with the formation of sodium oxide or potassium oxide. Now sodium oxide, previously we have also considered that sodium oxide, metal oxides and hydroxides are bases. So sodium oxide is a base, or potassium oxide is also base, and those bases are formed by the reaction between direct combination of sodium or potassium with oxygen. So this is one of the important method for the preparation of bases directly from the metals by reaction with oxygen, Na plus O2 Na2O, or potassium plus O2 K2O. Now see some other metals like calcium or magnesium. Now calcium and magnesium, they are reactive, but they are not so reactive like sodium or potassium. Sodium or potassium, they are highly reactive. After that, calcium and magnesium, they are reactive, but the reactivity is much less with respect to sodium or potassium. They also react with oxygen. With the formation of calcium oxide, or magnesium reacts with oxygen with the formation of magnesium oxide. But these reactions happen at an elevated temperature. Okay, at an elevated temperature, at higher temperature. Magnesium also burn in presence of oxygen at higher temperature. But in case of sodium or potassium, at normal temperature, at ordinary temperature, they react with each other. In case of calcium and magnesium, some temperature, some heating is required to react them with the formation of calcium oxide and magnesium oxide. So this is only the difference between these two reactions. Here, sodium and oxygen or potassium and oxygen, they react at ordinary temperature. Because sodium and potassium is highly reactive. But if you repeat this reaction in case of calcium and magnesium, then some amount of heat is required. Otherwise, reaction won't be happen. So some heating is required when calcium and oxygen reacts with the formation of calcium oxide, or magnesium and oxygen reacts with the formation of magnesium oxide. So this is a method where directly metals converted into metallic oxides, that is bases. Now, base can be prepared from basic oxides. How? Basic oxide when react with water, they also produce some base, because hydroxide and oxides both are basic in nature. Here you see that potassium oxide is basic oxide. It is basic oxide. Sodium oxide is basic oxide. So potassium oxide when reacts with water produces potassium hydroxide. This is also base. Or already we have considered that metal oxides and hydroxides are bases. Okay. So potassium oxide reacts with water with the formation of hydroxide. Hydroxide is also base. Sodium oxide is also reacts with water with the formation of sodium hydroxide, is also base. So basic oxide maybe react with water with the formation of hydroxide. Those are generally considered to be base. So metal directly reacts with oxygen, and metallic oxide reacts with water to form bases. Here you see some sodium or potassium metals. They, when added into water, sodium or potassium when added into water at normal temperature, sodium and potassium, they produces hydrogen. Sodium and potassium, they produces hydrogen. Here you see that sodium when added into water, it produces sodium hydroxide and hydrogen, and lots of amount of energy. This energy is so much heat is liberated in this process that hydrogen burns. So when sodium is added into water, hydrogen burns, and some lightning or some high amount of energy liberated by this process. So sodium and water, this is cold water, not the hot water, this is cold water. So sodium is so much reactive, highly reactive. They react with the water with the formation of sodium hydroxide and hydrogen, or potassium. They also potassium or lithium. They also react with cold water with the formation of corresponding hydroxide and hydrogen. So this is another method. Alkali metals directly react with water with the formation of hydroxides, that is base and hydrogen gas. So this is another method where alkali metal react with water directly, cold water react with water to form basic hydroxide or base. Here you see that potassium reacts with water to form potassium hydroxide and hydrogen, and also sodium reacts with water to form sodium hydroxide and hydrogen. Next method of preparation, bases from salts. You can convert salts into base. Like aluminium chloride. Aluminium chloride is a salt. Aluminium chloride is a salt. It reacts with sodium hydroxide to form aluminium hydroxide. Aluminium hydroxide is a base. Metal hydroxide, that's why it is a base. Now, ferrous sulfate reacts with sodium hydroxide, producing sodium sulfate and ferrous hydroxide. This is also base. So, aluminium chloride may be converted into aluminium hydroxide. Aluminium chloride is a salt. This is salt. This is salt. And this is base. So salt may be converted into base by the use of sodium hydroxide or potassium hydroxide. Here also ferrous sulfate is a salt, and ferrous sulfate is converted into ferrous hydroxide. In this way, you can convert salts into bases like aluminium hydroxide, like ferrous hydroxide, or even ferric hydroxide, etc. This is another method where the salts may be converted into bases through decomposition reaction. This is a well-known decomposition reaction, but the lead nitrate, here you see that lead nitrate on heating produces lead oxide, nitrogen dioxide, and oxygen. So lead nitrate is a salt. Lead nitrate, when heated, it produces lead oxide, nitrogen dioxide, and oxygen. Now lead oxide is a metallic oxide and it is a base. So lead nitrate is a salt and it is converted into base, that is lead oxide. So through decomposition reaction, this is a decomposition reaction. As we all know that decomposition reaction means single reactant converted into two or more different products is known as decomposition reaction. And decomposition reaction can be done by heating or even in presence of light or by using electricity, etc. But here this is thermal decomposition reaction. Thermal decomposition reaction means those decomposition reaction, those are those are executed by the application of heat. Here you see that lead nitrate is converted into lead monoxide. Another example like calcium carbonate. Calcium carbonate is a salt, but on heating, this is a symbol of heat. Okay, delta. On heating, calcium carbonate is converted into calcium oxide and carbon dioxide. So this is another reaction. You have to remember those reactions. There's so many methods by which you can prepare bases. Here we give examples of some reactions where decomposition of the salt may be used to produce bases. So lead nitrate may be converted into lead oxide, or the calcium carbonate or magnesium carbonate again converted into magnesium oxide or calcium oxide by thermal decomposition. So this is the reaction lead nitrate when reacts only by heating produces lead oxide, nitrogen dioxide and oxygen. You know what is the color of lead oxide? Anyone can say what is the color of lead oxide? Lead oxide,
Dark yellow, I guess.
sorry,
When hot, white when cold.
When hot, white, when cold.
what is the color of lead oxide?
Sir, yellow when hot and chocolate brown when cold.
Chocolate brown.
So
So
white when cold.
this is actually yellowish brown.
Yes.
This is actually yellowish brown. Yellowish brown. Zinc oxide is actually yellow when hot and white when cold. But this type of behavior is not shown by this lead monoxide. This is yellowish brown color and nitrogen dioxide is a reddish brown color. So lead nitrate may be converted into lead monoxide only by thermal decomposition reaction. So these are the important important methods for the preparations of acids and bases. Now we discuss the different properties of acids and bases, both physical and chemical properties. First of all, we should discuss about the physical properties of acids. Physical properties of acids. This is very common, that is, taste of acid is generally sour. Can you give any example? Can you give any example where acid having bitter taste? Do you know? Do you know any acid? Name of any acid. Which is bitter in taste, not sour. It's bitter in taste. No idea.
No, sir.
Note it down. Picric acid. Picric acid is one. This is organic acid. Organic acid. I think this is the only acid having bitter in taste. Having bitter in taste. If you want to know what is the formula of picric acid, then I should say that formula of picric acid is something like this. OH, it contains 3 NO2 groups. NO2 groups.
Sir, একটা কোয়েশ্চেন ছিল।
Yes.
স্যার, টেস্ট কি করে ডিপেন্ড করে একটা কম্পাউন্ডের?
টেস্ট অ্যাকচুয়ালি মানে সল্টের ক্ষেত্রে একরকম হয়, অর্গানিক কম্পাউন্ডসের ক্ষেত্রে জেনারেলি কি হয় না, টেস্ট হচ্ছে ক্যাটায়নিক ক্যারেক্টারিস্টিক্স। ক্যাটায়নের জন্যই একটা টেস্ট হয়, ক্যাটায়নিক পার্টের জন্য, পজিটিভ পার্টের জন্য। অ্যানায়নিক পার্টের জন্য সেরকম একটা টেস্টের ভেরিয়েশন হয় না, ক্যাটায়নিক পার্টের জন্যই হয়, একটা ক্যাটায়নিক ক্যারেক্টারিস্টিক্সের জন্য হয়। সাপোজ সোডিয়াম ক্লোরাইডের যা টেস্ট, মোটামুটি সোডিয়াম সালফেটেরও তাই একই রকমের টেস্ট, বা পটাশিয়াম সালফেটের এই সোডিয়াম নাইট্রেটেরও একই রকমের টেস্ট হবে, কারণ সোডিয়াম পার্টটা হচ্ছে টেস্টকে ইম্পার্ট করে। তো তার কিছু মেকানিজম আছে, কিন্তু সেটা নিয়ে আমি আলোচনা করছি না, কিন্তু জাস্ট for your information, that tastes are generally the cationic characteristics of a salt. Cationic characteristics হচ্ছে যেগুলো সল্টের। Now, general information is that acids are generally taste sour. Picric acid is only exception. Second one, they turn blue litmus paper red. Already we have discussed that the litmus paper taste, where red litmus paper blue, then it is alkali or base, or blue litmus paper red, it is actually acid. Turn methyl orange red. It can convert the methyl orange is an indicator, synthetic indicator. Litmus is a natural indicator. But methyl orange is synthetic indicator. Methyl orange convert uh, to red color when acid is added to it, or methyl orange when added to acid, then methyl orange turn to red. All the acids, more or less, all the acid having corrosive action on skin, because most of the acids, when comes in contact with skin, some exothermic processes occur, and that's why burning of skin is quite obvious, and that's why corrosive action of skin. Or even if you consider the acids like sulfuric acid, then sulfuric acid is highly hygroscopic. It is highly hygroscopic. We have already completed sulfuric acid chapter. Then in that chapter you see that sulfuric acid is strong dehydrating agent. It absorbs the water part from the skin and creating some burning sensation into the skin. So almost all the acids having corrosive action on skin, like some of the organic acid, they don't have such a corrosive action, like vinegar, that is acetic acid, or even citric acid, etc. So except organic acid, mostly the inorganic acid like hydrochloric acid, like nitric acid or sulfuric acid, they having high corrosive action on skin. Now next point is that number 5, that is a good conductor of electricity. Now why acids are good conductor of electricity? Only because of the fact that acids, when you consider like hydrochloric acid or even nitric acid, so nitric acid or hydrochloric acid, they dissociate in aqueous solution with the formation of H plus and nitrate ion, or even hydrochloric acid dissociate into H plus and Cl minus ions. Now when we we electrolyze this nitric acid, then those compounds are good conductor of electricity. They produce ions in solution, because ions are only responsible for the conduction of electricity in solution. Because of the fact that different acids like nitric acid, sulfuric acid, hydrochloric acid, they are easily dissociates with the formation of cations and anions in the solution. Sulfuric acid dissociates with the formation of H plus and SO4 minus. Nitric acid dissociates with the formation of H plus and NO3 minus. And that's why you can say that acids, they conduct electricity, because these ions are responsible for the conduction of electricity. So you can say that acids are good electrolyte. Last one, that is acid when diluted. Now if you add some hydrochloric acid or sulfuric acid, sulfuric acid into water, some heat is liberated. Most of the time, acids when diluted, some heat is liberated because the dissolution of acid into water is exothermic process. So dissolution of acid into water is exothermic process, and that's why when acids dissolve in water, they produce much amount of heat. And this heat generally known as heat of solution. This heat also termed as heat of solution. Okay. So these are the important physical properties of acid. They taste sour, they convert blue litmus paper into red, they turn methyl orange into red, they having corrosive action on skin, and they are good conductor of electricity only because of the fact that they convert into ions. They generate heat when diluted because the process is exothermic. So these are the important physical properties of acids. Now, the acids have some chemical properties. Now, chemical properties in sulfuric acid chapter, we use this type of diagram, like this type of diagram, where the acidic character of any acid, that acid may be sulfuric acid or maybe hydrochloric acid or maybe nitric acid, etc., etc. So all the acids having some general reactions, like acid react with active metals. Like active metals means like aluminium, like zinc, like iron. Those metals are highly reactive. Those active metals, they react with acid with the formation of salt and water. Next one, that acid reacts with carbonate or bicarbonate salt. They always produce carbon dioxide and salt and water. They react with sulfide salts, produces hydrogen sulfide. We give some examples also. Sulfide salt or bisulfide salt, they produces salt, sulfur dioxide, and on reaction with base, metallic oxides and hydroxide, they produces salt and water. Now we give some examples. These are the chemical properties of acids. Now, what happened when acid react with zinc or iron? Like dilute hydrochloric acid, zinc plus dilute hydrochloric acid with the formation of zinc chloride and hydrogen. Zinc also react with dilute H2SO4 to form zinc sulfate and hydrogen. Zinc plus dilute HNO3. What happened? Can you say? Can anyone say?
Na2ZNO2 হবে
Na2ZNO2. Na আবার কোথা থেকে এলো? Only zinc reacts with dilute nitric acid. What happened?
জিঙ্ক
So,
নাইট্রেট ফর্ম করবে
zinc nitrate and
হাইড্রোজেন
no.
ওয়াটার
Previously, we have considered that nitric acid is a very strong oxidizing agent. So, sulfuric acid or dilute hydrochloric acid, they do not have such oxidizing power. So, in those cases, zinc chloride and hydrogen or zinc sulfate and hydrogen forms. But when you use dilute nitric acid, then zinc nitrate plus nitrogen dioxide and water forms. So hydrogen is oxidized by dilute nitric acid. Hydrogen is oxidized by dilute nitric acid with the formation of water. So that's why nitric acid is not used to prepare hydrogen gas in the laboratory. This is the cause why nitric acid is not used to prepare hydrogen gas in the laboratory. Though we should use dilute hydrochloric acid do not have any oxidizing power. Dilute sulfuric acid also do not have any uh, oxidizing power, or very small, very less oxidizing power. Concentrated sulfuric acid are good oxidizing agent, but dilute sulfuric acid is not a good oxidizing agent. So in those cases, zinc can react with dilute hydrochloric acid or dilute sulfuric acid to produce hydrogen. But once you use nitric acid, the dilute nitric acid, is a very good oxidizing agent. Though in concentrated scale or in dilute scale, in both the cases, nitric acid is a good oxidizing agent. That's why they oxidize hydrogen with the formation of water. Now move on to second one, that is the metallic oxides. When metallic oxide reacts with acid, like sodium oxide react with acid like H2SO4, produces salt and water like sodium sulfate plus water. Or take example like magnesium oxide reacts with HCl, produce magnesium chloride plus water, salt and water. Like zinc oxide reacts with hydrochloric acid to produce zinc chloride plus water. So any acid, either it is sulfuric acid or nitric acid or hydrochloric acid, whatever may be the acid, it reacts with basic oxide with the formation of salt and water, salt and water, salt and water. Copper oxide also reacts in the similar manner. Now metallic oxides, now metallic hydroxides. How metallic hydroxide reacts with acids? Like sodium hydroxide. It reacts with phosphoric acid. What is the product? बोलो क्या प्रोडक्ट होगा यहाँ पे? Sodium hydroxide when reacts with phosphoric acid, what should be the product? अभिका बोलो क्या होगा?
Sir, sodium phosphate.
Sodium phosphate. What is the formula of sodium phosphate? Very good. Sodium phosphate is the product and water. So just tell me what is the formula of sodium phosphate.
Sir, Na3PO4.
Very good. Very good. Na3PO4. This is sodium phosphate. Na3PO4 plus water. So
Yes.
sodium phosphate and water. This is salt and this is water. So phosphoric acid, this is acid, reacts with sodium hydroxide to form sodium phosphate and water. Now another one, that is zinc hydroxide. It reacts with like what we take, that is the HCl is common example, that is ZnCl2 and water. So acid can react with base, that means metallic hydroxide or metallic oxide, with the formation of salt and water. Now next one, that is acids always reacts with carbonate salts. Any carbonate salt, it reacts with the formation of, always remember, carbonate salts react with acid to form salt, carbon dioxide and water, salt, carbon dioxide and water. If anyone asks that how will you identify acid without using any indicator, how will you identify an acid without using indicator? then what should be the answer? How will you determine the acid? How will you identify the acid without using indicator? Now, this is the answer of this question, that when any carbonate salt react with acid with the formation of carbon dioxide. So take a test tube, and that test tube half filled with acid. Now add solid few crystals of sodium carbonate. What happened? Some effervescence bubbles of carbon dioxide. You should observe some bubbles of carbon dioxide, and that bubbles of carbon dioxide is formed in this reaction, and this is a good uh, important chemical property of any acid. So if you want to identify an acid without using indicator, without using the indicators like litmus paper or even phenolphthalein or methyl orange, etc., you have to just add sodium carbonate or bicarbonate salt, even or even you can use bicarbonate salt. Bicarbonate salt may also react with acid, like this. Bicarbonate, this is bicarbonate, sodium bicarbonate, NaHCO3. They react with acid with the formation of sodium chloride, carbon dioxide, and water. So if you want to identify acids, then you can use this type of reaction where the carbonate or bicarbonate salt, any carbonate or bicarbonate salt, they produce carbon dioxide. প্রতিকৃত
স্যার বলছি এটা উইক অ্যাসিডের জন্য অ্যাপ্লিকেবল?
weak acid like carbonic acid can participate in this reaction, but the acids like I remember one particular acid, that is, do you know this name of this acid? This is phenol. Generally known as carbolic acid.
হ্যাঁ স্যার, নাম শুনেছি।
This carbolic acid, it does not produce carbon dioxide on reaction with bicarbonate or carbonate, because carbolic acid is so weak. Other organic acids like acetic acid, formic acid, or even citric acid, lactic acid, these are oxalic acid. All those weak acids, organic acids are generally weak. Organic acids most of the time weak. This type of acid, what I give example of those acids like formic acid, like acetic acid, vinegar, that is vinegar, or even citric acid present in citrus fruits, or tartaric acid, or malic acid. All those acids, those acids are considered to be weak, but all those acids produces carbon dioxide on reaction with sodium carbonate or sodium bicarbonate. But here is an only example, that is the carbolic acid. Chemical name is phenol. Carbolic acid do not produce carbon dioxide on reaction with sodium bicarbonate. Okay. So this is exceptional because carbolic acid is so weak, very very weak, so it does not produce carbon dioxide on reaction with bicarbonates. Now another important reaction, that is the sulfite, sodium sulfite. Here you see sodium sulfite. When reacts with acid produces sodium chloride, sulfur dioxide, and water. Now these two are similar reaction. Sodium carbonate reacts with HCl with the formation of sodium chloride, carbon dioxide and water. In this reaction, sulfur dioxide form, and in this reaction carbon dioxide forms. Sonal,
So you said that carbolic acid is a very weak acid and it does not produce carbon dioxide on reaction with bicarbonate. So is it same with carbonate also?
साउंड क्रैक कर रहा है, हम ठीक से सुनाई नहीं दे रहा है,
सर
दोबारा बोलो.
अब सुनाई दे रहा है? हेलो सर.
हेलो.
Is it clear now?
Yes, clear. बोलो.
Yes. So I was asking कि you said that carbolic acid is a very weak acid and it does not react to produce carbon dioxide in reaction with bicarbonate. So is it the same with carbonate also?
Carbonic acid reacts similar way with carbonate or bicarbonate.
Okay, sir. Thank you.
In
Okay,
both
sir.
the cases, either carbonate or bicarbonate, in both the cases it does not produce carbon dioxide. Carbolic
Okay.
acid is very weak.
Okay, sir.
Now here I give two examples like sodium sulfite and sodium carbonate, and in this reaction, in these two reaction, only difference is that here sulfur dioxide evolves and here carbon dioxide evolves. Now can you say any chemical method to identify or to distinguish carbon dioxide and sulfur dioxide from any reaction? How will you differentiate between carbon dioxide and sulfur dioxide? Apart from their smell, sulfur dioxide having burning sulfur smell, but carbon dioxide do not have such smell. But I want to ask question in such a way that I don't take any physical differences. I only consider chemical differences, that how you should differentiate between sulfur dioxide and carbon dioxide. Can anyone answer this question?
Sir, quick lime turns milky. Lime water turns milky when when passing carbon dioxide through lime water. It turns milky.
Okay. Now let me clear one thing. That is the most important part of this question is why I am asking this question, because of the fact that carbon dioxide and sulfur dioxide both turns lime water milky. Carbon dioxide and sulfur dioxide both turns lime water milky. So the appearance of milkiness in lime water does not prove that that particular gas is either carbon dioxide or sulfur dioxide. It can only prove that that gas may be sulfur dioxide or maybe carbon dioxide, but you never confirm in this test that that gas is carbon dioxide or sulfur dioxide. So this is not the distinguishing test. In this level,
Answer.
yes,
Can I answer?
yes,
So I guess sulfur dioxide turns potassium dichromate, acidified potassium dichromate, orange to green.
very good,
And when does
very
not.
good. This is the actual answer, that sulfur dioxide has that different property, that is it convert acidified potassium dichromate when add some acid to it and then pass sulfur dioxide through it, then potassium dichromate having orange color, and this orange color is converted into chromic sulfate, that is the green color. Due to the reducing property, this reaction should be happen only because of the fact that reducing property reducing property of sulfur dioxide. Sulfur dioxide has reducing property. It is a reducing agent, and that's why it can convert potassium dichromate into chromic sulfate. But this reaction is not responded by carbon dioxide only because of the fact that carbon dioxide is oxidizing agent. Oxidizing agent, carbon dioxide do not have any reducing property. Do not have any reducing property of carbon dioxide. Sulfur dioxide has both oxidizing and reducing property. So this is a very good answer from Sonal. Potassium dichromate, orange colored potassium dichromate. So when you pass any gas through lime water, if lime water milky, then that gas may be sulfur dioxide or carbon dioxide. And after that, you have to perform the second test, that if that particular gas turns the acidified dichromate paper green, then that gas will be sulfur dioxide, but otherwise that gas will be carbon dioxide. So it is a very important question. Avika, bolo.
सर पोटाशियम मैंगनेट भी यूज हो सकता है
पोटेशियम
पोटाशियम मैंगनेट
manganate nahi,
Permanganate.
potassium permanganate. Yes, that can also be, also you can use potassium permanganate, KMnO4. There is a purple color. This is purple color, and it's acidified solution. When reacts with sulfur dioxide, it produces MnSO4, that is colorless. So this test can also be used to identify sulfur dioxide gas, because sulfur dioxide gas also reacts with potassium permanganate to produce colorless manganese sulfate. Okay. Some sulfide salt. These are the sulfide salt, like sodium sulfide, reacts with hydrochloric acid, produces hydrogen sulfide and sodium chloride. Hydrogen sulfide and sodium chloride. Or even zinc sulfide, it reacts with HCl with the formation of hydrogen sulfide and zinc chloride. Or ferrous sulfide reacts with hydrogen chloride to form hydrogen sulfide and ferrous chloride. Now this is hydrogen sulfide. This is hydrogen sulfide. Now, can you say what is how you should identify hydrogen sulfide? How you should identify hydrogen sulfide? Do you remember any taste of hydrogen sulfide?
Sir, rotten egg smell chilo.
Rotten egg smell. Already I have mentioned that I ignore about the physical properties of any gas, physical properties like color or like odor, etc. Just answer according to the chemical properties of those gases. Can anyone answer me? What is the identification? How you should identify hydrogen sulfide? Apart from that deadly rotten egg smell. Okay. In the laboratory, you get some compounds like lead acetate. This is lead acetate. Lead acetate, OCO-CH3. This is known as lead acetate. This is white in color. Okay, white in color. Now, in contact with hydrogen sulfide, or if you pass hydrogen sulfide into lead acetate solution, then you should get lead sulfide and acetic acid. Now this lead sulfide is black lead sulfide. So hydrogen sulfide may be identified identified by reaction with lead acetate to form lead sulfide, which is black in color. So this is the chemical test. By which you can identify hydrogen sulfide gas. So identification of different compound is very important from chemistry point of view, because the chemical properties uh, generally chemical properties are used to identify those gases. There are so many gases having pungent smell or bad smell, or even smell like these, like that, etc. But those tastes should not be considered as the confirmatory taste, or you should confirm about the gas present in a reaction mixture, etc. That's why the identification test is so much important um, for the gases. Now, chemical properties of the acids. Already we have mentioned that potassium nitrate or sodium chloride, this type of salts may be converted into nitric acid or hydrochloric acid, and this reaction should be maintained around temperature below that of 200 degrees Celsius. Above 200 degrees Celsius, they form sulfate salts, which are sticky in nature and difficult to remove from the glass container, etc. etc. We have already mentioned. This is one of the important chemical properties of acids. Normal salts or more volatile acids are displaced by the less volatile or the non-volatile acid. Now, what are the important properties of bases? Bases are generally bitter in taste. They are soapy to touch, etc. Soapy to touch, and bases generally they give pink color or purple color on uh, contact with phenolphthalein, or even they change the color of methyl orange also. They react with acids with the formation of salt and water, etc. These are the common. They are also good electrolyte. Bases are also good electrolyte. They conduct electricity in solution. They change the color of the litmus paper, and also they, when dissolved in water, some amount of heat is liberated, like sodium hydroxide. When sodium hydroxide is dissolved in water, that sodium hydroxide is dissolved in water, but some excess amount of heat produced. So these are the common physical properties, of bases. So these are not so important. Now we move on to chemical properties of bases. Now, chemical properties of bases. How you should prepare ammonia from ammonium salt. This is very important question. How you should prepare ammonia from ammonium salt? Like ammonium salt means like ammonium sulfate. Ammonium sulfate, when reacts with strong base like sodium hydroxide, it produces sodium sulfate and ammonia plus water. So this is the principle, that any ammonium salt, in place of ammonium sulfate, you can also use ammonium chloride. So any ammonium salt, ammonium sulfate, or maybe ammonium chloride reacts with sodium hydroxide to produce sodium sulfate and ammonia and water. This is the general method for the preparation of ammonia in the laboratory. If you want to prepare ammonia in the laboratory, then this is one of the useful method, where the ammonium salt reacts with sodium hydroxide or potassium hydroxide to produce ammonia. But though ammonium nitrate is also ammonium salt, but ammonium nitrate is never used to prepare ammonia. Just think about the fact that any ammonium salt like ammonium sulfate, ammonium chloride, they react with sodium hydroxide with the preparation of ammonia gas. Now ammonium nitrate is also the ammonium salt, but you never see this type of reaction where ammonium nitrate reacts with sodium hydroxide to produce ammonia. Why? The general principle is ammonium salt reacts with sodium hydroxide to produce ammonia. Then ammonium nitrate is also ammonium salt. Then why we can't use ammonium nitrate with sodium hydroxide to produce ammonia in the laboratory? Do you have any proper explanation of this? If ammonium sulfate or ammonium chloride can be converted into ammonia by sodium hydroxide, then why not ammonium nitrate? Bodhikrit?
স্যার সোডিয়াম নাইট্রেট ফর্ম করতে অসুবিধা হবে?
Sodium nitrate is a good, important chemical that is available in the market, like sodium sulfate, ammonium sulfate, or ammonium chloride. No. Actually, the problem is ammonium nitrate is explosive in character. Ammonium nitrate, when get some heat, it produces N2O plus water. This is a self-decomposition. Ammonium nitrate easily dissociates with the formation of nitrous oxide and water. This reaction is explosive. That's why ammonium nitrate is not used to prepare ammonia gas in the laboratory. Okay. So ammonium salts, other ammonium salts like ammonium sulfate, ammonium chloride, etc. can be used to prepare ammonia in the laboratory. Here you see that ammonium chloride reacts with sodium hydroxide with the formation of sodium chloride, ammonia, and water. Now the other chemical properties like metallic salt solution. Any metallic salt solution gives precipitate. Like metallic salt solution means like copper chloride, CuCl2. It reacts with sodium hydroxide with the formation of copper hydroxide and sodium chloride. The color of the precipitate can be used to identify the metal ion present in the solution. Now, what is the color of copper hydroxide? Sonal, what is the color of copper hydroxide?
Blue.
Sorry?
Blue, I guess.
Copper hydroxide is pale blue. Pale blue precipitate. It is so a solution if contains copper ion, then on reaction with sodium hydroxide you can easily conclude that solution from the color of this precipitate, that is pale blue precipitate. It is the identification of copper hydroxide, and you can identify the copper ion present in the solution. Here also ferric chloride reacts with sodium hydroxide, produce ferric hydroxide. Ferric hydroxide. Ferric hydroxide. What is the color of ferric hydroxide? What is the color of ferric hydroxide? Do you know?
Reddish brown.
Reddish brown. Very good. Reddish brown ferric hydroxide. Uh, in this connection, what is the color of ferrous hydroxide? Ferrous hydroxide.
Dirty green.
Dirty green. Very good. So ferric hydroxide, this is reddish brown. Reddish brown. Here also, the reddish brown precipitate confirms the presence of ferric ion. Zinc sulfate also reacts with sodium hydroxide with the production of zinc hydroxide. This is also precipitate and sodium sulfate. So zinc hydroxide, what is the color of zinc hydroxide?
Gelatinous white.
Gelatinous white. Gelatinous white. Gelatinous white. So I just want to mention some of the metal ions over here, because the metal ions on reaction with sodium hydroxide or potassium hydroxide, they produces a particular type of precipitate. That precipitate can be confirmed their presence of ions in the solution. There may be other ions like ferrous hydroxide, already mentioned, aluminium hydroxide, even lead hydroxide, or calcium hydroxide. All those compounds having their characteristic color, and due to this characteristic color, we can identify through these reactions. So this is the important application of bases. Important application. Sometimes this can be asked in the question paper, that how will you explain the usefulness of bases for the identification of metal ion in solution? Give example. Okay. How bases can be used to identify the metal ions in solution? That some of the examples are given here. That is, the metal ions reacts with sodium hydroxide or potassium hydroxide, produces some precipitate having characteristic color. Precipitate may be formed in different reactions also. This is not such an important thing. But if precipitate has some characteristic color which can be used to identify a particular metal, then this reaction will be a useful one. So this is one of the application of this chemical property of base, is one of the application of base. Now lastly, today we discuss about the neutralization reaction. What is neutralization reaction? The neutralization reaction means when acids and bases, they react with each other, neutralize each other with the formation of salt and water, and this reaction is known as neutralization reaction. Here you see that the process due to which the H plus ions of an acid react completely or combined with OH minus ions of a base to give salt and water only. This is the neutralization reaction, when the acids give H plus and the bases give OH minus, and those H plus and OH minus, they get attached with each other with the formation of salt and water. Here you see that acid give H plus, it reacts with OH minus with the formation of sodium chloride and water. This is salt and water. So neutralization reaction is such a reaction where the acids and bases, they completely neutralize each other. You should get a solution which do not have any characteristics of acid or do not have any characteristics of bases. So that reaction, this type of reaction is known as neutralization reaction, where the neutralized acids or bases neutralize each other. Like this neutralization reaction, here you see that acids produces H plus and the base or alkali produces OH minus. This H plus and OH minus, they react with the formation of water, and the other part, that is the sodium ion and the chloride ion, they react with each other, they attach with each other with the formation of sodium chloride. So these are some important properties, and the preparation today we discuss some of the important properties and important reactions. Here you see the nucleation reaction. We take some base and add some phenolphthalein. Now, after the addition of phenolphthalein, that phenolphthalein is in acid it is colorless, but in base it is pink in color. So, because of the fact that this is pink in color in the test tube, so it contains the base. Now we add dropwise some of the acids to convert it into colorless. That means that acids totally neutralize the base present in the test tube because of the fact that phenolphthalein changes its color. That means it contains some amount of acid excess, in the test tube, and that's why you can say this is a neutralization reaction. Though this neutralization reaction, when again you add some base, then it again converted into pink color. That is, again it contains greater amount of base. So acid can neutralize the base, or base can neutralize acid in this way. So today we complete this part, that is the preparation of acids and bases, also their chemical and physical properties. Next day we we again take some MCQ or assertion reasoning type questions from this part today, this part which today we have discussed, that is the chemical and physical properties of the acids and also the preparations of acids and bases. Okay, so I share this PDF in the group, and prepare yourself that in the next class, first 20 minutes we should take the MCQ or assertion reasoning type short answer type test, and after that we should continue the next portion of this chapter. This is most important part of this chapter, that is the conception about pH. pH means the acid and base property, how we identify what is pH and the applications of pH. So today बस इतना ही आज के क्लास शेष करलाम. Good night to each and everyone. Again we meet next class next Wednesday at 10 p.m. Okay, thank you, bye.
Bye, sir. Thank you, sir. Good night, sir.
Good night.